Okay, so this one I'm going to look at as a multiple choice question. It says an electrical circuit consists of three identical resistors of resistance R connected to a cell of EMF E and negligible internal resistance. What's the magnitude of the current in the cell? Okay, so what we're going to need to do here is first of all work out the equivalent of these three resistors. So those two that are in parallel here, these two, they're both R and R. So resistance of those is going to be 1 over R plus 1 over R. It's going to end up being R over 2. So then I've got the situation where those two are the same as R over 2. And I've got the other one here of R. So the total thing is going to be the same as if the circuit was like that. And the resistance of this was 3 over 2R, because I've got R over 2 from this one and then another R here. So it's the same as if it was 3R over 2. Then I can use that, what do I need here? The current. So V is equal to IR. So the current is going to be the voltage over the resistance. So the voltage, it says EMF is E. And then we're going to divide that by 3 over 2R. So the 2 would move to the top. So it's going to be 2E over 3, which is 3R, sorry, which is B. So the answer is B. Okay, so this time we're going to do a slightly more involved question. So it says X and Y are two lamps. X is rated at 12 volts, 36 watts, and Y is 4.5 volts, 20 watts. Calculate the current in each lamp when it's operated at its correct working voltage. Okay, so to do this, we need to know that power is equal to I times V, the current multiplied by the voltage. So we're asked to work out the current, so the current is therefore going to be the power divided by the voltage. So for X, it's going to be 36 divided by 12, which is 3 amps. And for Y, it's going to be 2 divided by 4.5. 2 divided by 4.5, 0.44. Okay, that's how we do that one. So let's move on to part B. It says the two lamps are connected in the circuit shown in figure 1. The battery has an EMF of 24 volts and negligible internal resistance. The resistors R1 and R2 are chosen so that the lamps are operating at their correct working voltage. Okay, and we've got our circuit set up like that. First of all, it says calculate the PD across R1. So that's the potential difference. That's basically, it wants to know the voltage on this voltmeter here. So it said here the resistors R1 and R2 are chosen so that the lamps are operating at their correct working voltage. In the first part of the question, it told us that X is rated to 12 volts. So basically what that's saying is that the potential difference across here is going to be 12 volts. Since the supply is 24 volts, and we've got 12 volts between this point and this point, which is the same as this point and this point, 12 volts will be between these 2 points, so that would leave the other 12 volts to be between these 2 points, which is the same as here. So this would be 12 volts, this would be 12 volts here. Okay, next it says calculate the current in R1. So again, if we go back to our previous part of the question, so because resistors R1 and R2 are chosen so that the lamps are operating at the correct working voltage, then that would mean the currents should be as we calculated in part A. So the current through X along here should be 3 amps. And then the current through Y along here should be 0.44 amps. Now those two branches are going to flow along and they're going to meet here. So as we come along around here, we should add those two together and we should get 3.44 amps. Also along here, we would get 3.44 amps because they would have to divide up at this point here. 0.44 going this way, 3 going this way. So the answer to that one would be 3.44. And then part B3 says calculate the resistance of R1. So in this part, we'd need to use V is equal to IR. Rearrange that so resistance is V divided by I, and then use the two answers we had in the previous part. So it would be 12 divided by 3.44. So 12 divided by 3.44 is going to give us 3.49. So that would be the resistance of R1. Okay, next it says, the filament of the lamp in X breaks and the lamp no longer conducts. It's observed that the voltmeter reading decreases and lamp Y glows more brightly. Okay, so let me rub out what's going on here. So, what would happen then is this part, lamp filament here would break, so that part would no longer be available. So what would happen now is the current would only flow around this way. So we've effectively got a series circuit going around here. Like that. Okay, since the filament in X is broken. Now, because the filament X is broken, what we've done is we've actually increased the resistance of the circuit because we've taken away an extra branch that the current could flow through. So because the current can no longer flow through X, the total resistance of the circuit is going to increase. So, since the current no longer flows through X, total resistance increases. Since the resistance increases, that would mean the current will decrease, and then here, since the resistance of this is the same, V is equal to IR. If the resistance is the same, the current is decreased, the voltage will decrease. V is equal to IR, so V decreases. Okay, then next it says, explain without calculation why lamp Y glows more brightly. Okay, so we've just said that the voltage here, this decreases. Decreases. Okay, decreased like that. So that would mean if the voltage across here has decreased, then the voltage between here and here would have to increase between these 2 points here. Since the voltage here is decreased, the 24 is still the same, so the voltage here would have to increase. So the voltage across Y would increase. Therefore, the current through Y would increase, and it would glow more brightly. So, voltage across Y increases. So, I don't think we need to worry, actually, so we can just say that hence more power is dissipated. Okay, so it glows more brightly. Okay, so in these kind of questions here, we've got 2 marks to get, so I've maybe done a slightly more detailed explanation than would be required, but 2 marks and 2 marks, we do need to explain at least 2 things what's going on. So I said here the voltage across Y increases, so therefore it's going to glow more brightly. In this one, I've said the current no longer flows through X, so the resistance increases, therefore voltage is going to decrease.